Qualcomm just announced something that could reshape consumer tech, and almost nobody's paying attention. They've built a processor called the Snapdragon Reality Elite, engineered specifically for next-generation augmented reality headsets. Here's the shocking part: this could put mainstream AR in consumer hands within 18 months. Right now, a decent AR headset like Apple's Vision Pro costs $3,000 or more. They are bulky, they drain batteries in hours, and they're really only for enthusiasts and enterprise teams. Qualcomm's new chip changes that completely. The Snapdragon Reality Elite is built from the ground up to deliver AR experiences on lightweight, affordable hardware. We're talking devices hitting the market under $400 while matching performance of systems that cost 3 times as much today. This isn't Qualcomm's first AR processor, but the leap here is enormous. They've finally cracked what the industry has chased for years, delivering console-quality graphics, responsive hand tracking, and spatial computing while keeping power consumption low enough for all-day wear. That combination unlocks an entirely different market. The real story isn't just about what was announced yesterday. It's about what gets built into your home, your office, and your pocket over the next 18 months. And here's where it gets interesting. To understand why this announcement matters, you have to go back to the fundamental problem with AR, augmented reality. Overlaying digital information onto the real world around you is phenomenally demanding. Your AR system needs to track your hands in 3 dimensions in real time. It needs to understand the physical space around you, walls, tables, people, and render digital objects that look like they're actually sitting on those surfaces. It needs to do all of this while displaying everything at high refresh rates so it feels smooth instead of nausea-inducing. That requires an enormous amount of processing power. Until now, the only way to get that processing power in a wearable device was to accept major trade-offs. You've either got limited performance but good battery life, or you've got great performance but a device so power-hungry it needs charging every few hours. Alternatively, you offload some processing to a smartphone or nearby computer, but then you introduce latency, that lag that breaks immersion. The AR market has been stuck in this trade-off zone for years. That's why Apple's Vision Pro costs so much and why it's not a consumer device yet. That's why most AR is still phone-based, limited, but practical. Qualcomm's breakthrough is that they've finally found a better path. But here's what most coverage gets wrong. So what's special about the Snapdragon Reality Elite? It's partly new architecture, more processing cores, better efficiency for spatial computing tasks. But the real breakthrough is something more subtle. Qualcomm engineered this chip with AR's actual demands in mind, rather than adapting a general-purpose processor. Think of it like the difference between a car engine and an engine built specifically for racing. The Reality Elite's architecture prioritizes the tasks AR constantly does: visual tracking, spatial mapping, gesture recognition. Those are deeply woven into the chip's design, not bolted on as an afterthought. It's got specialized hardware, dedicated circuits, for processing the camera feeds and LiDAR sensor data that help AR systems understand where you are and what you're looking at. That specialization matters because it means less battery drain. The chip doesn't waste energy computing things it doesn't need. It's lean, focused, and efficient. Qualcomm's architecture teams also improved the graphics performance dramatically. The chip can render complex 3D scenes, photorealistic objects, dynamic lighting, intricate detail, faster and with better quality than previous generations. Early benchmarks put it at 40% faster rendering than the previous top-tier processor, all while using less power. That gap between performance and efficiency is what makes the difference between a $3,000 device and a $400 device. Here's the twist nobody expected. So what do you actually do with all that performance? The most obvious answer is consumer AR, the kind that might ship on your next smartphone or tablet. Imagine AR that understands your room well enough to place virtual furniture and let you visualize how it'll look before you buy it. Imagine gaming where digital characters walk around your actual living room and react to your real surroundings. Imagine productivity apps where you're wearing lightweight glasses that overlay information directly into your field of view, work documents, navigation, communication feeds, all without touching your phone. But the consumer applications are just the beginning. Enterprise applications drive a lot of innovation in spatial computing. Repair technicians wearing AR glasses could see diagrams overlaid on the machinery they are working on, with step-by-step instructions displayed right in their view. Surgeons could reference medical imaging during operations. Architects could walk through buildings before they are built. Scientists could visualize molecular structures in 3D space, manipulate them, understand them in ways that flat screens don't allow. Manufacturing, logistics, training, nearly every field has a use case for accurate, responsive spatial computing. The Snapdragon Reality Elite makes all of that accessible at a much lower price point. That performance per dollar jump opens entirely new markets. The devices that become possible aren't just incremental improvements over what exists. They are fundamentally different products for fundamentally different use cases. And that's just the beginning. How does the Snapdragon Reality Elite actually stack up against what exists today? Apple's Vision Pro runs on Apple's M2 chip paired with custom spatial computing processors. It's incredibly powerful, but also power-hungry and expensive, $3,500 with regular charging required. Meta's Quest Pro uses an older Qualcomm processor, capable, but a generation behind. Microsoft's HoloLens runs custom processors. These existing systems aren't directly comparable because they are built for different purposes, different markets, different price points. What matters is the trajectory. Previous generation Qualcomm AR processors were good enough for phone-based AR and entry-level head-worn devices. The Reality Elite jumps into Vision Pro performance territory while maintaining the efficiency profile that makes devices affordable. We're not talking about matching the Vision Pro's capabilities at half price. We are talking about matching them at 1/5 the price while getting 18 to 24 months of additional software optimization. By the time a Reality Elite-based device ships in volume, the software ecosystem will have caught up, the manufacturing will be optimized, and you'll be looking at devices that cost $400 to $600 while delivering 80% of the Vision Pro experience. That changes which market this product targets entirely. Those aren't premium alternatives to the Vision Pro. They are consumer products for a completely different category. Here's what the headlines aren't telling you. This announcement is an inflection point for AR. We are moving from the question, is AR real, to when does AR become normal? The Snapdragon Reality Elite is the chip that makes the second question answerable. The market changes when price to performance crosses a threshold. Smartphones took off when they became capable enough and cheap enough that people wanted them instead of just being curious. We are at that threshold for AR. Within 18 months, you might see your first genuinely mainstream AR device. It won't be from Apple. The Vision Pro is their luxury play and they'll keep it premium. It'll be from companies like Meta, Qualcomm's partners, maybe fresh startups already building prototypes with this chip. Those first mainstream devices will be limited compared to the Vision Pro. Less processing power for other tasks, perhaps simpler displays, lower resolution, but they'll be light, they'll be affordable. They'll have all-day battery life, and that's what breaks the adoption barrier. Once AR devices become practical, cheaper than a high-end smartphone, lighter than sunglasses, lasting all day, the trajectory becomes inevitable. Your next device purchase might eventually include AR. Your kids' classrooms might use AR for education. Your workplace might standardize on AR glasses for information display and collaboration. That's not speculation anymore. That's the timeline the Snapdragon Reality Elite opens up. Here's the thing that changes everything. So how does a chip specifically engineered for AR actually work differently from a general processor? It starts with the instruction set. The fundamental operations the chip is optimized to perform quickly. A general-purpose processor like the one in your phone has to be decent at everything: video decoding, email, photo processing, gaming, social media. That means it's truly excellent at very few things. An AR-specific chip prioritizes the operations that AR constantly needs: matrix multiplication for neural networks, the kind used in hand tracking and object recognition; vector operations for spatial calculations; graphics pipeline operations for rendering 3D scenes. These aren't just faster on the Reality Elite, they are architecturally optimized. The chip also has dedicated accelerators, specialized hardware units for specific tasks. There's dedicated silicon for video decoding from multiple camera streams, There's dedicated silicon for processing LiDAR and depth sensor data. There's a separate visual processing unit that handles camera feeds in real time. When you have hardware specifically built to handle a task, you get orders of magnitude efficiency compared to running that same task on general-purpose cores. That efficiency difference is why the Reality Elite can deliver Vision Pro-level performance while using maybe one-third the power. It's not magic. It's focused engineering. It's understanding the actual workload and building silicon optimized for that specific job. But wait, there's something nobody's talking about. Here's what this means for you. The AR devices you've been hearing about aren't coming in 5 years anymore. They're coming in 18 months. They're not luxury items. They're consumer gadgets, the next logical upgrade cycle. That change happens because of engineering breakthroughs like the Snapdragon Reality Elite. Qualcomm didn't invent AR, and they're not the only company building AR processors. But they've engineered something genuinely novel, a processor delivering high performance with low power consumption, enabling a completely different market. The company that builds the first mainstream AR device using this chip will shape how the entire industry evolves. Within a decade, AR will be as normal as smartphones are today. Within 5 years, it'll be unremarkable. Within 18 months, the first affordable consumer products land in people's hands. This is what technological inflection looks like, the moment when an engineering problem finally gets solved well enough that the market opens up. This is that moment. The Snapdragon Reality Elite proves the moment has arrived. If you want to understand where tech is actually heading, follow for daily AI and tech headlines. We cover the breakthroughs that matter, the announcements that change what's next, and the analysis that helps you understand what it means. Follow for daily AI news.